What are they? Gamma ray bursts are brief blasts of gamma radiation. They are the second most brightest event in the universe, with the Big Bang being the brightest. Gamma ray bursts are presumed to be correlated with the formation of black holes and the emission of jets of matter during the death of a massive star.
Different types of gamma ray bursts. Short gamma ray bursts last less than 2 seconds, with the average time being 0.3 seconds. These types of bursts appear to be associated with the merger of two neutron stars into a new black hole, or a neutron star merging with a black hole to form a bigger black hole. Long gamma ray bursts can last from 2 seconds to several minutes, with the average time being 30 seconds. They are associated with the deaths of huge stars and supernovas, although not every supernova creates a gamma ray burst.
When were they discovered? GRBs were discovered in the late 1960s. They were discovered by U.S. Vela nuclear test detection satellites. The Velas were built to record gamma radiation pulses released by nuclear weapon tests in space. How were they discovered? A research and development program used Vela satellites to detect gamma radiation. The satellites conveyed X-ray, gamma ray, and neutron detectors. The X-ray detectors are used to sense the flash of a nuclear blast. The Nuclear Test Ban Treaty. The U.S. Air Force launched the first in a series of satellites to monitor the protectiveness of the Nuclear Test Ban Treaty. The treaty was signed on August 5, 1963, by representatives of the United States, the Soviet Union, and Great Britain. They approved of not being able to test nuclear devices on Earth or in space.
Swift satellite. The Swift satellite is a satellite from NASA that is dedicated to observing gamma ray bursts. Within seconds of the Swift satellite detecting a burst, it gives the location of the burst to ground stations, allowing the ground and space-based telescopes to observe the burst's afterglow. The problem. The surface of any planet in the path of a gamma ray burst would be burned to a crisp. Some scientists think this might limit the number of planets. This could possibly threaten the amount of planets with intelligent life.
The solution. Unfortunately, there is not really a solution for gamma ray bursts because they are too powerful and there is nothing humans can do to stop them. But we will probably never be hit with a burst because most bursts happen in small metal-poor galaxies. But the Milky Way is a large galaxy that contains many heavy elements. This is a visual representation of a short gamma ray burst. These neutrons are the remains of a huge star's core that had exploded as supernovas long before. These two stars orbited around each other hundreds of times per second, dispersing gravitational waves. After the stars collided, they produced a gamma ray burst in a flare-up hardly ever seen called a kilonova. Here is a diagram of a gamma ray burst. To the left is the black hole engine. From there are the low-energy gamma rays. Past the shells, there are colliding shells that emit low-energy gamma rays, which is internal shock wave. And past that, the jet collides with ambient medium, which is external shock wave. This produces high-energy gamma rays, X-rays, visible light, and radio in the afterglow.
This video represents a long-term gamma ray burst. As you can see here, the gamma ray bursts are different from supernovas because instead of exploding in every direction, gamma ray bursts focus all of their energy in one area to create a sort of beam, making the beam extremely powerful. This shows the star dying, and as the star is dying, it creates a gamma ray burst that can last over 15 minutes. Conclusion. In conclusion, gamma ray bursts are important for scientists to research the end products of massive stars and help study high-energy astrophysics. Not only are gamma ray bursts really interesting, but they are also very scary.
Created using Powtoon.